All right, today I'm going to show you how easy it is to make a battery. So to make a battery, we need two dissimilar kinds of metals. I have copper and zinc here. And then you need some kind of electrolytes. You need something in between them. Preferably an acid or a base, but salt water will work. So for example, if I took the copper and the metal and I put it in a lemon, bam, bam. Now I get, if I measure it, I get 0.96. You can see it's minus, so I really want to flip it around. So that means that, do I still get 0.96? Yep, 0.96 volts. So lemon battery, just sticking zinc and copper in it, are giving me almost a full volt of potential energy. So you saw that this was positive, so copper is the positive and the zinc is the negative. Um, so that basically means that I have more electrons accumulating in the chemical reaction that takes place. We are gaining electron in the zinc. So we can do this with almost any material. It doesn't have to be a lemon. Lemon obviously have lots of acid. Here I did the same thing on potatoes. So I have two potatoes, and that's enough to run a little clock. So it's putting out enough voltage and current to run a clock module. This guy will run for probably up to about a month before the potatoes dry out. So it produces enough to power simple electronics. I can also do it with a simple household. I have my coffee cup right here. So if I pour my coffee in, and this is regular coffee, I can grab my zinc and my copper, and you can see I get 0.65 volts, so or 0.68 just from the coffee. So Gatorade would work, salt water would work, anything like that. You can also do it out of household items. So pennies right here, copper clad, there's zinc on the inside of them. So we could go in and we could take sand one end that expose the zinc, and then we have copper on one end, zinc on the other side. I bought zinc washers instead. That was pretty easy. I also took cardboard. So we're going to have the electrolyte in the middle and a separator, right? So I take cardboard, I cut it into basically the approximate piece of my penny in my washer, and I trim the corner. I put that in regular vinegar right here. So I'm going to fish these guys out. So these guys were soaking in vinegar for maybe like 5 minutes or so, enough to hopefully get them wet. So I'm going to take them and I'm just going to dry them out. Bam. So now that I have these, I can take a penny, copper penny, and I can take a zinc washer. And again, if I measure this, I have 0.78 volts. So this guy is a cell. So we tend to refer to everything as a battery, but basically if we have one anode and one cathode, one positive and one negative with an electrolyte in the middle, that is a cell. So technically this battery has an anode and a cathode, just one. So this technically, even though we refer to it as a battery, technically is a cell. So check it out. Here I have a 9-volt battery. This guy is a battery because alkaline, that chemistry tends to give you about 1.5 volts. So just like with the 1.5 volts in this guy, if I open that up, I actually have 6 batteries inside hooked up in series. So that boosts my voltage. So this guy is a battery because it has 6 different cells inside of it. But in life, we tend to refer to everything as a cell. As a battery. So now I can make a bunch of different. So now I have another cell right here, right? Bam. Bam. This guy, again, is about 0.84. Now, if I take my 2 cells, I can stack them in different configuration. If I stack them like this, where I have common bottom for the zinc, common top for the copper, it's in parallel, I would get more current out of them. If I put them on top of each other, they're in series. So basically, negative, positive, put them straight on top of each other. Now I have 1.3 volts. So in essence, this guy is about the same voltage right now as a big alkaline battery. What's the difference between them if they have the same voltage? This guy can put out more current. And current typically has to do with how much surface area are on your anode and your cathode. In batteries, we tend to wrap them around. So if I took some of these guys, especially a NiCad battery, if I open it up, the anode and the cathode, instead of just being a little stack, like two elements, a lot of time wrap around, so they have a lot of surface area. When we talk about car batteries that can put out a lot of voltage, that becomes an issue. But let me make some more cells. So I have another cell right here. I have another cell right here. I have another cell right here. Bam. Another cell. Another cell. And another cell. So now I'm going to take all of these guys. I had 1.5. If I stack these guys on top of each other, I should have 2 point something. 1.88. So one of them is not very good of my cells. I have some issues. In real life, they tend to be very predictable, but I'm using cardboard and vinegar. 2.5. Add another one. 3.3. Add another one. 4.0. Maybe Tosh is available here. Get it? 4.75. So I can keep going, but you can see if I take an LED, I can light an LED. If I taped this guy up, move this guy so you can see it better. If I actually tape this guy up to prevent them from drying out, this guy would light up for probably about a couple of days or maybe even as long as a week from the current I have available. And typically it's going to stop working because the cardboard with the vinegar dries up. I could soak it a little bit and it would work again. So making a battery, super simple. 2 dissimilar metals, an electrolyte and a separator in the middle, and it could be almost any material or anything, any solution. So coffee worked great. Vinegar works really good. Hydrogen peroxide works very well. Salt water, Gatorade, any of those things will work. So I hope that explains a little bit about batteries. Also, this guy now is a voltaic pile. So it's really a miniature version of the same battery that Alexandria Volta made back in the 1800s that changed everything. So a little bit about batteries right there.